Alright everybody, welcome to the first of two videos that are going to cover the material from section 10.2. This one's going to go over the definitions and some simpler examples, and then the next video is going to go over a little more complicated examples. You'll be seeing both of them in the homework assignment, so if you want a little bit of help just knowing what to do for the problems, I would recommend watching both of them. But this is going to lead to two slightly shorter videos than if I had made one longer one, so hopefully you'll like that aspect of it. We got a few definitions to start out, and then we'll see a few examples. So what we are going to see here then is these terms first. Alright, so starting with the central angle. The idea of a central angle is we start at the center of the circle defined in the last video, or mentioned in the last video, and what we're going to do is we're going to make an angle coming from the center basically to the circle. We're going to make an angle with the circle here. Formal definition for a central angle is just an angle with the vertex at the center. Remember that a vertex is the sort of the hinge on the angle. It's the part that connects both of the rays that go off of it. So that's good. Now, the angle that I formed here, let me call this C for center. I'll call this point up here A and this point B. The space in between, actually I don't want to start there. I want to start with semicircle. A semicircle is basically a central angle with endpoints on a diameter. So, if you imagine that, let me just make an extension off of this one here and call this point D. Angle BCD would be a semicircle, because you can see it's going through the center C, and it has endpoints on the circle. That's meant to be a straight line going through BCD. So that right there is a semicircle. They always have 180 degrees. Which is to say that since two semicircles make up a whole circle will always have 360 degrees, just like the quadrilateral. Reason I wanted to do semicircle first is because minor arc and major arc are based on semicircle, kind of like obtuse and acute angles are based on right angles. A minor arc is an arc, and we'll talk about what an arc is in a moment, with a measure less than 180 degrees, and a major arc is an arc with a measure of greater than 180 degrees. Arcs are the space on the circle that is sort of taken over by the angle that's there. So if we look at angle ACB here, the arc that it associates with that is this one right here. The sort of jaggedy lines. The way that we usually label arcs is we would say that this is AB, and then we'll have a little arc over it like that. An example of a major arc here would be if we had arc, and you can sometimes use three letters to describe arcs. You can really do two or three depending on what you're trying to do. But if you look at arc A, D, B, the rest of the circle, arc ADB would be a major arc. You can see how it's more than the semicircle. It's bigger than that. It's bigger than 180 degrees. So that's good. Congruent circles are pretty much what you would expect them to be, and congruent arcs are pretty much what you would expect them to be. Congruent circles are circles with the same radius, and congruent arcs are arcs with the same degree measure. So just like all things that are congruent, basically it means that they have the same things. Two of them that are exactly the same. The measure of an arc is equal to the measure of the central angle completing it. In other words, in our picture, if angle ACB was 80 degrees, then arc AB would also be 80 degrees. So let's see this play out in a few of our examples here. Right, so we need to determine whether we have a minor arc, major arc, or semicircle, and then find its measure. Starting with the measure of arc MN. Well, here's MN, and remember the measure of an arc is the same as the measure of its central angle that creates it. We see that the angle here at the center is 70 degrees, which means that this arc, MN, is also 70 degrees. That would make it a minor arc, because it's less than 180, and we know it's 70 degrees. So that's not too bad. Next one we have is the measure of NQ. NQ we see is, let me label it in a different color. We're going to say that NQ is this one here. We could go the other way, but usually when you're given two letters, you're going to want the shorter path between them. So we're going to take that one for NQ. Now, we know that this little guy here is 30 degrees, but we don't know what this one here is at the moment. Thing is, MOQ is creating a semicircle, and semicircles have 180 degrees. So, if we know that we have 70 degrees from here and 30 degrees from here, that means that the angle that we're missing has to complete the 180 degrees. That means that the missing angle and the arc size of NP itself is 80 degrees. We know that PQ here is 30, because 30 plus 80 plus 70 is 180. What that means then is that NQ is 80 plus 30 degrees, which is 110. That's another minor arc. C has us look at NQR. So I'll choose a different color again. NQR. So starting at N, going through Q, ending at R. We got this right there. Those endpoints are both on a diameter, and R is a diameter. So that means that that's a semicircle. Has to be. And it also means that it has to be 180 degrees. MRP. All right. So MRP is starting at M, going to R, finishing up at P. So it's this big arc right there. You can see that M all the way to Q, starting at M, going to Q, that's a semicircle, 180 degrees. But we're adding this 30 in from PR. So 180 plus 30 is 210. That makes this a major arc. It's greater than 180 degrees. The measure of MR then is our next one. So starting at M, going to R, this section right here. NR is a semicircle, so 180 degrees. We already know that we have 70 here. So that's going to make this 180 minus 70, which gives us 110 degrees for MR. And that's a minor arc, less than 180. Lastly, we have MQN. So that has us start at M, go to Q, and finish at N. You'll notice that that's including almost the entire circle, everything except for NM. There are 360 degrees in a whole circle, two semicircles put together. 360 minus 70 is 290, and that's going to be the angle measure here. That is a major arc, given that it is over 180 degrees. So, what we want to look at here then is, are these arcs congruent? And then we'll want to explain. Looking at this first one. So here's the thing. Are these arcs exactly congruent? Well, not really. Yes, they do both have 65 degrees, which means that this is a 65-degree arc. And this is also a 65-degree arc. But if we were to measure the lengths of these two arcs, they would not be the same measure. AB, the circle that contains AB, is clearly a little bit bigger than the other one, which means that the length of AB is going to be longer than CD's length. So these ones are not congruent. And if you wanted the explanation, you could write down what I just talked about there. This one here, let's see. Well, 135 plus 115 gives us 250. So these combined are 250, which means that there's 110 left over here. I would say the circles look like they're the same size this time. So, since these arcs both have a measure of 110, and the circles are the same size on this one, I would say yes, they are the same. So the big difference there is, were the circles the same size? Were they not? Also in the example for number 4, these are not congruent circles, but in number 5 they are. Congruent circles lead to congruent arcs if they are the same size. If your circles are not congruent, you're going to have a harder time getting to those congruent arcs. So that is part 1 of section 10.2. Another video to watch coming up after this that will go through more theorems, a few more examples that are a little tougher than these ones. So, hope to see you in that video as well.